So now we're going to demonstrate the pot meter. So here we have the pot meter. It has two potentiometers, a 50 microamp meter. Conveniently, for at 50 microamps with a 100 kilo ohm series resistor, we can show full scale at 5 volts. This is connected to the digital to analog converter on the circuit here, which is an I2C 4-channel ADC and 1-channel DAC connected to I2C. We can control it with I2C. This is the one that has the address 4E. We can change the address using these switches very conveniently and hook up multiple into the system and very nicely change those switches so we don't have a conflict with the address. So this is our pot meter system, you can see here, and what we're going to show is a capability in the Java Pyroraptor software in order to test these pot meters. Now these pot meters are very convenient. Not only you have these adjustable, these nice knobs for the pot meter, and we're going to use that to control the pan and tilt, but we also have these things called Java beans. Let's go ahead and take a look at the graphical interface. I'm going to hit a tab called ADCs and DACs, and you see these Java beans here. I'm going to zoom in, and what I'm going to do is type in the address of the pot meter, which is 4E. So here we're showing the Java Pyroraptor user interface on the tab, as we mentioned, for ADCs and DACs. We show 4 Java bean meters. The top 2 meters are connected to the ADCs associated with the potentiometers on the pot meter. The bottom 2 are grounded actually on the pot meter, so the ADC is at ground, so they're always going to show 0. And what I'm going to do here is start a process. We have a thread running here, and we have the address of the pot meter, I2C address 4E hexadecimal, and here we are going to sample the ADCs at 300 millisecond intervals. Let's go ahead and start running this guy. Now the pot meter, I'm going to be changing the potentiometer, and you can see the Java bean showing where the potentiometer is, going from 0 to full scale. Let's go slow and fast. Now let's move the other one. 0, full scale. Let's put both of them at midpoint. So for you to get an idea, I'm going to show the pot meter right here. And what I'm doing is changing these knobs here. There you go. Let's go ahead and change this one. Let's go ahead and change this one. Change this one. Okay, so you can see that by changing the knobs, I can change the voltage, measure that through the Pyroraptor, and then I can use the output of the ADC through the knobs to use the knobs to control our pan and tilt system, which we will describe next. Over here I'm going to go ahead and stop this thread. I'm going to go to the tab that says pan and tilt ultrasonic. See here, let me go ahead and zoom in. One of the things you'll see in the corner here is we can type in an interval. Let's put in 400 milliseconds to sample, and here we have a checkbox which I'll click, which says use the potentiometers in order to control the pan and tilt. So what I'm going to do is start running this guy, and you heard the motors move. Let's go ahead and zoom out. There's our pan and tilt. Here's our pot meter, and what I'm going to do is change the potentiometer and move this guy around. There you go. Go slow. Move it all the way. Move this guy all the way so you can see the pan and tilt moving with the knobs. Very nice. So all this capability is available in this tab here, and we can also do individual setups of the pan and tilt and just do an update. We can also scan, which it is doing as we speak. So if you look at the pan and tilt, you'll notice that the LED here is turning on and off. Let's go ahead and zoom in. That's your scanning. And you'll notice that the Java bean here shows the distance from the ultrasonic. So I'm going to put my hand in front of it, and you see it go to 0. Then I'm going to move it away, slowly move it away, and it measures a longer distance. And if I completely move it away, that's the furthest. And then I come in, 0, move out. So very nicely, as we are sampling every 400 milliseconds, we are also scanning and measuring the distance with the ultrasonic and showing that on the Java bean. So I've been moving around and it can see different distances. Let's go ahead and use the pot to tell this guy to go look at the ceiling here. And you can see that's full scale, furthest distance. Let me put my hand in front of it and it comes back to 0, move it away, and come back, slowly move the hand away. You can see it's measuring the distance, completely move it away. We're at the furthest because it's looking at the ceiling. So this is a very nice system. Let me show you what I was doing. So here we have the pan and tilt looking at the ceiling, and I'm putting my hand in front of it, and you can see the Java bean go to 0. Let's get it right in front of it. It's 0. As I move it away, the needle moves. Completely move it away, it's looking at the ceiling. And I can adjust the tilt. Let's get the pan. Here's the tilt. Now I'm looking at the monitor, and you can see the meter. And as I move, you'll see the meter move as it makes measurements. Let's go ahead and look at the monitor, toward the monitor. Okay, here's the pan. Let's go look at the monitor. There you go. Let's move it away from the monitor. There you go. Now it's looking at me. Let's go ahead and look at the ceiling. Let's come back, look at the monitor. Okay, so nice system here for experimenting with the I2C based servos in a pan and tilt configuration with ultrasonic. Very nice way to get into robotics, get this guy working, and then you can not only put this on the robots like a rover, but you can also start building up a rover or an arm with multiple I2C motors with multiple degrees of freedom. Alright. Okay, so now we're going to pack this guy in. So let's go ahead and show the system. Zoom out. Let's get the case. Okay, so here we have the Harbor Freight case over here. And first thing we do is cut the power to the system. Hear the fan go off on the power supply, cut the USB. We're going to disconnect the power pole. Set this guy on the side. Very nicely take out the pan and tilt. Take the whole system. Make sure the USB cable doesn't come with it. Here's our case. Put it in there. There we go. Make sure there's no wires sticking out. Close it. Ready to transport and do more experiments.